it's Olivia here from Olivia's Online Tuition, and today is day 10 of my 25 Days Better Maths Grade series, and today is the topic of box plots. So I have made a worksheet for today's session, so it's going to be in the description, linked down below. So I would recommend printing it off before you start the video, so that then you're super prepared and you have all the grids that you need, all the tables that you need, so you can draw along with me. But yeah, other than that, we'll do some practice questions first, and then on to exam questions. Yeah. Let's get to it. Okay, first question then. The table shows some information about the heights in centimetres of some plants. We've got the minimum, lower quartile, median, upper quartile and maximum. So 5 lines on a box plot and conveniently 5 numbers in this table. So minimum is the first one we plot. So let's put that where 11 goes, which is here, 1 after 10. And the minimum is just the smallest, like the smallest plants, essentially, the lowest height of all the plants, right? That's the minimum point, nice and self-explanatory. The lower quartile, which is at 28, which is here, the lower quartile refers to the plants that's like a quarter of the way through all the plants, right? So say if you have, I don't know, a list of plants, that's going to be the minimum, that's going to be the maximum, and then a quarter of the way through is like roughly like, maybe a bit less than that, maybe like here, right? Roughly, reasonably. Does that make sense? Roughly. So a quarter of the way through, that's the lower quartile, that's 28, which is there. The median is the middle plant, so you're taking a feeler at the ends, a quarter in the middle, which is then the median, which is 37, 5, 6, 7. Okay, then the upper quartile, which is 3/4 of the way through the data, which is then 42, which is this guy here, and then 51, which is this one here. And then all we need to do is connect all those up. So the heights I've done these at is just purely for aesthetics. I like the middle bit of the box plots to be like double the height of the bits on the ends. That's just aesthetics. You could just make it all the same height, or make the box smaller than the end bits, or whatever you fancy, right? As long as everything, all these 2 lines are the same height and these 2 are the same height, doesn't really matter, whatever you fancy. Yeah, that's the first question. Question 2 then, the table shows some information about the heights in centimetres of some tomato plants in Maggie's garden. So we've got minimum, lower quartile, median, upper quartile and maximum, and then draw a box plot for this information. So again, just putting all these down. So minimum is going to be 12, which is there. Lower quartile, 27, which is 5, 6, 7 there. And then median is 35, which is here. Upper quartile is 42, which is here. And then maximum is 55, which is here. And then connect all these up. Okay, and then draw your lines on. Easy peasy, job's a good one. And there we are. Then part B, there are some also tomato plants in Nigel's garden. Who'd have thought? The box plot below shows the distribution of the heights of Nigel's tomato plants. Okie dokie. Part B then is compare the distribution of the heights of Maggie's plants with the distribution of the heights of Nigel's plants. So whenever you see this phrase, this compare the distribution, they're always looking for the same stuff. Okay, they always want exactly the same thing. So first thing they want is an average. And the average you're going to use, like 9 times out of 10, is going to be the median. That's what we have in these box plots here. It's going to be the median. That's going to tell you about the tallest, or whatever context they're in. The one that scores the highest, I don't know, the shortest, I don't know. So whatever they're measuring, going to tell you who's best at whatever they're measuring. The next thing they're going to want to know about is either the interquartile range or the regular range. Range. I always just use the regular range. Doesn't really matter. You can use interquartile range, essentially just upper quartile, take lower quartile. But I just like to use the range, just highest, take lowest, because we're used to that, aren't we, with the range? Been seeing that since like year 7 now. So we use the range, and that tells us about consistency. Consistency. So, are Nigel's plants all really tall, or are they all really short, or they have a big old spread, right? Is the difference between the tallest and the shortest really, really, really high? That's what the range tells us. Who has the most spread out heights of plants, right? So then let's have a look at this. So the average, so the median, I should say, for Maggie's, that's going to be this number here. So for Maggie, the median is 35, and that's versus the height, so the median for Nigel's, which is 25. So what that means is that on average, Nigel's plants are a lot shorter, 10 centimeters in fact, and on average, Maggie's plants are taller. That's what that means. And then the range, then, let's work out the range of these two. So highest take lowest, 55 minus 12, which is 43 for Maggie. 43. That's versus for Nigel, we've got 58, take away 8, which is 50. Okay. So, Nigel has a larger range. The difference between his smallest plant and his tallest plant is larger. Does that make sense? So, his plants are more spread out height-wise. So, Maggie's are more consistent. So, all you need to do then is usually write that out in sentences. So I'll write it out for you, then I'll show you what I put. Okay, then this is what I would put. So on average, Maggie's plants are taller as the median is higher. The heights of Nigel plants are more spread out as the range is higher. And that would always get you 2 marks. So all they're looking for here is a comparison on an average and a comparison on a range. That's what they're looking for. If you get both of those down and what that means in the context, you're going to get 2 marks. So there we are. That's the second question. Okay, next up then, the cumulative frequency graph shows the weight in grams of 60 apples. The apples had a minimum weight of 163 grams and a maximum weight of 188 grams. Draw a box plot to show the distribution of the weights of the apples. So combining cumulative frequency with box plots. So you still need all the same lines on it, so you still need min and max, so tallest and shortest, or heaviest and lightest. You need those. And then you need upper quartile, you need lower quartile, and you need median. Still need all those 5 points. Okay, so min and max, that's easy. That's what they've told you. So minimum is 163. Maximum is 188. And then upper quartile, lower quartile, and median, you're going to find using this graph here. So lower quartile is a quarter of the way through the data. That's always 1/4 of the way through. Upper quartile is always 3/4 of the way through, and median is always half of the way through. So what we do for that is, okay, we find the apple that's 1/4 of the way through all of the apples, which is going to be 60 times 1/4, or 60 by 4, which is 15. So the 15th apple will be the lower quartile. The 45th apple will be the upper quartile, which is 3/4 times 60, and the 30th apple will be the median. Let's work that through then. So the 45th apple is going to be here, which is then going to be going down to there, which is, let's have a look at that, 175. And then the lower quartile is going to be 1/4 of the way through, which is 15, which is that number there. And then going down to here, which is 165. And the median, the 30th apple, which is this guy here. And then going down to this guy here, which is 170. And then just put all these points with that. And then let's connect all these up. And there you have it. Easy peasy. And there we are. Okay, so the first exam question then, we've got the AQA June 2017 paper 2, question 16. So pause it, have a go, see how you get on. Okay, then so question 16 here is a box plot. Circle the median value. So the median, if you recall, is this one in the middle. So we've got, this one is min, this one is lower quartile, this one here is median, this one upper quartile, and this one here is max. So we need this value here, which is, they go up in 2, so 22, 24, 26, 28. There we have 1 mark. Okay, next up then, another AQA question, November 2017, paper 3. So again, pause it, have a go, see how you get on. Okay, then question 13. Here is some information about the length of time cars stayed in a car park. Shortest time was 30 minutes, longest time was 12 hours, Lower quartile is 2, interquartile range was 3 hours, and median was 4. So we have everything we need apart from the upper quartile. Let's put that down here. So we need the upper quartile, right? But we have been given this extra little tidbit here, right? So we should know that the interquartile range is the upper quartile minus the lower quartile. So the interquartile range, they told us, is 3. That's going to be equal to the upper quartile. Take away the lowest quartile, which is 2. So in order to get 3, 5 must be in the upper quartile, because 5 minus 2 is 3. So the upper quartile, add that to the list, that is going to be 5 hours. So let's just plot it then. So shortest time is 30 minutes, which is like half an hour, right? So in hours, that's going to be down here, like so. And then longest time is 12 hours, so that's going to be like here. Lower quartile is 2 hours, so that's going to be like there. And then upper quartile, I should say, is going to be 5 hours, which is going to be like there. And then median is going to be 4 hours, which is going to be about there. Then connect them all up. That one with that one, that one with that one, and then that one with that one, and that one all the way over there. And that would be 3 marks. Okay, next up then, an Edexcel question this time. Edexcel June 2017, paper 3, which is calculator. So again, pause it, see how you get on. Okay, and then question 9. The box plot shows information about the distribution of the amounts of money spent by some male students on their holidays. Okay. Part A is work out the interquartile range for the amounts of money spent by these male students. So, interquartile range, that, if you recall, is the upper quartile, take away the lower quartile. So upper quartile could be this amount of money here, which I'm going to go from here all the way down here, which is 3 to 5, because they go up in twos, and then that's in the middle, so make it 5. So 3 to 5. Take the lower quartile, could be this one here, which is also kind of awkwardly in the middle, very annoying. Which is, I think, 1, what is that, 4, 5? Okay, and then take those away, calculate paper, so use one if you got one. 3, 2, 5, make away 1, 4, 5, which is 180. And there we are. And then part B, the table shows information about the distribution of the amounts of money spent by some female students on their holidays. On the grid above, draw a box plot for the information in the table. Okie dokie then. So, smallest, lowest, lower quartile, median, upper quartile, largest. Everything we need, easy peasy, just need to plot it all on. And there we are, 2 marks, easy peasy. And then Chris says, the box plot shows that the female students spent more money than the male students. Is Chris correct? Give a reason for your answer. This is the female students here that we've just done. So remember, spent more money, that means median, comparing the median, because who's better, who's spent more money, that's going to be an average, that's a median. Remember, consistency is range, and then comparing the two properly, that's the median. So, whose median is greater? It's the females, isn't it? So, is Chris correct? Yes, he is, as the median for the females, hate that word, but oh well, is greater. And there we are. That would be all the marks. Okay, last question then. Question 12, which is an Edexcel November 2017 paper 1 question. So again, pause it, have a go, see how you get on. Okay, then question 12. The table shows information about the heights in centimetres of a group of year 11 girls. Okay, there we have it. Draw a box plot for this information. Let's make it started then. So least height, that's a minimum, so let's put that on. It looks awful on my screen. I hope it looks better in your printout. Median 165, which is going to be here. No lower quartile, wonder why. And then lower quartile, oh, there it is, 161, which is here. Okay, oops, a daisy, which is, give me another chance to get this line right. There we are. Interquartile range, deal with that in a second. And then range, double is 20. So we're still missing the upper quartile and the max, right? So let's work with these. So interquartile range, that is upper quartile minus lower quartile. We know the inequality range, that's 7. The upper quartile was, we don't know. The lower quartile, oopsie, take away. Lower quartile is 161. What minus 161 is 7, I should say. And that's going to be 168, isn't it? Take that is going to be 7. So let's put a marker down. And 168 is going to be, that's 5. So 6, 7, 8 is going to be about that one. Again, if I'm slightly off, take pity on me because this is really small on my screen. Well, it'll be a lot easier to see on yours. And then range is 20. So range is max take min, which is going to be, so that's 20. Maximum is what we don't know. Take away the minimum, which is 154. That's going to be 50, 60, 70. So 174 minus 154 is going to be 20, because that's the difference of 20 between these numbers. So 174, that is going to be there. Make it the small line. That one there. And then connect all these up. And there we have it. That is your box plots. There we are. Moving on then. Part B then. The box plot below shows information about the heights in centimetres of a group of Year 7 girls. Compare the distribution of the heights of the Year 7 girls with the distribution of the heights of the Year 11 girls. So remember with this, comparing two things. Range, which will tell us about the consistency, and average, which is in this case the median, which will tell us who is taller. Change that. It will tell us who is taller. One with the greatest median is going to be taller. So I'm going to then type it out and then I'll show you what I get in a second. Okay, so this is what I would put. I would put on average, the Year 11 girls are taller as they have a higher median, because the Year 11s have a median of 165, whereas the Year 7s have a median of about 157, like that. So they have a higher median than Year 11, so they're going to be taller. And then the range for the Year 7 girls is smaller, so they are more consistent, because the range of these guys is going to be 170, take away 146, which is 19. And the range for this one, of the Year 11s, is 20, so therefore 7 girls have a smaller range, therefore they are more consistent. And that is that. And there we have it. That was day 10 of my 25 days Better Maths Grid series on box plots. Hope you've enjoyed. If you did, feel free to like, subscribe, comment, do all that YouTubey stuff. Tomorrow is the topic of transformations. Ooh, fun. I'm going to go through all the transformations with you. So hope to see you all there. Bye.